Good evening, everyone. We are going to present our project SageSoulRAG, a RAG-based chatbot with personality. This project has been developed by Team 4, consists of Aradhya, Bhavan, Saket, Sashi, and myself. Here is the project background. This project stems from the motivation to improve artificial intelligence-driven chatbots by creating a retrieval augmented generation-based chatbot with distinct personas, making interactions more personalized and engaging. It addresses the shortcomings of traditional rule-based chatbot, especially in customer service for finance and healthcare, offering a transformative impact across various industries. Moving to the next. This is the executive summary of the project. This project develops a chatbot that combines a knowledge base powered by Pinecone vector database with advanced large language models. This includes GPT-4o, Mistral 7b, Llama 3.2, and Gemma 2. The chatbot is fine-tuned to respond with a personality while meeting domain-specific needs. The goal is to compare the model performances and optimize responses for user engagement. We have reviewed several technology and solution papers for the existing AI application in conversational models, highlighting data sets, LLMs, and performance outcomes. For instances, include Mistral 7b for coding and reasoning tasks, and Palm 2 for language proficiency. Moving to the next slide. The key studies illustrate innovations in chatbots with personalities, such as using persona-based data sets and advanced embedding techniques. Models like RAG, bidirectional encoding, and adaptive meta-learning approaches improve user interactions. These insights from several literature survey papers guide the project's technical decisions, focusing on user engagement and domain relevance. Moving to the next. This project demands robust resources as part of the project that includes NVIDIA GPUs and vector databases like Pinecone. Several open source tools like Jupyter Lab, Google Colab, and Rapid API facilitate efficient data handling, model training, and integration. And here are the list of the software that has been used during the development. For example, Python libraries like Pandas for data preparation and so. The project methodology is based on the CRISP-DM framework, emphasizing a structured approach to data mining. It includes iterative steps such as data preparation, transformation, and model evaluation to achieve high-quality results. This is the project architecture. The project collects data from diverse domains such as finance and healthcare, which is then pre-processed through cleaning and augmentation before being transformed into dense numerical vectors using cohere embeddings. These embeddings are then stored in the Pinecone vector database, enabling efficient similarity-based retrieval for user queries. And then when a user inputs a query, the system identifies the most relevant documents based on vector similarity, converts them back to text format, and feeds them into a fine-tuned large language models. This models then tailored with persona-specific data sets like those of Robert Kiyosaki and Dr. Sanjay Gupta generate contextually accurate responses. Finally, the response is displayed to the user via the chatbot interface, delivering precise and relevant information or assistance.
Coming to data preparation, the data is collected for both the personas from free online edition books and podcasts and various video interview transcripts for Robert Kiyosaki and Sanjay Gupta. This slide shows the data downloaded from multiple sources like Internet Archive. For finance, we collected data from books by the US Treasury Department, Securities and Exchange Commission, and a Rapid API. So for healthcare, it is from McGraw-Hill's book on medicine and Rapid API as well for this. This shows the data that is collected from two APIs, that is real-time finance data and endless medical API. The above two figure shows the sample of financial system and current essentials of medicine book. This is the raw samples of data collected from real-time financial data API and medical data API respectively. These figures show the sample data from Mr. Robert Gayaski and Dr. Sanjay Gupta from various PDFs. As part of data pre-processing, like replacing word contractions with full form, handling URLs and special characters using text normalization is performed. Removal of extra white spaces and lemmatization is also performed as part of text normalization. As part of data augmentation, synonym replacement and back translation techniques are used. Also use text generation using GPT-2 for increasing textual data beneficiary for training models to generate coherent and contextually relevant text or longer sequences is performed.
So once all the data pre-processing steps are performed, we also went ahead in terms of creating question answer pairs, especially with respect to the persona data. This again is more relevant in terms of fine-tuning the large language models that we chose for this project. And for that, we have actually used PALM2 model in terms of generating the question answer pairs from the persona data that we provide. And all the QA pairs is stored in .json format. And this slide here, in fact, the picture here shows the chunk size along with the overlap size, where the chunk size is 4,000 and the overlap size is 300. And through this, we have basically created the question answer pairs for Robert Kiyosaki and Dr. Sanjay Gupta. So all this, so essentially, once we went ahead in terms of creating the QA pairs, we again once the end-to-end steps of data cleansing and pre-processing is performed, we save all that data separately in .txt format, where one file is for domain and the other file is for essentially the persona data. And once we get all that data, we read that .txt data, and then we have to vectorize it in terms of trying to store that in the vector database, which again in our use case is Pinecone. So for that, we have actually used Cohere embedding, where we have used the input data, where we have chunked the input data into 1024 characters with 24 characters as overlap. And as you can see in the below figure here, we have shown the vector embedding, which is the result of Cohere embedding. And this picture here shows the number of chunks which were actually created in terms of the whole vectorization process. And once we vectorize the data, then we end up storing that in the Pinecone database. And here, this is a picture where we have used the AWS storage account, uh, where the actual data is stored inside the Pinecone database, where here we have where we use the metric as cosine, which essentially is the similarity in terms of the searches that we perform on the vector database. And once we store all the data, we go ahead in terms of trying to ensure that the vector database actually is retrieving the right results based on our need, where we try to where we ask a question and it undergoes the entire embedding process, and then we get the top 5 matches to ensure that the data that we are getting is accurate. And once we ensure things are working fine, then the previously pre-processed data, where we have everything in a question answer format, we go ahead in terms of trying to split it in 80:10 ratio, where where the 80 part is the training data set, 10 is for validation, and 10 is for testing of it. Again, this is more in terms of data preparation for the LLM fine tuning. And this again is the entire data statistics in terms of how many in terms of the number of files that we processed for the raw data. And then once data pre-processing is done, we end up in 2 text files, one for domain and one for persona. And in terms of data transformation, we end up embedding the data, and then we store it in the Pinecone vector database. And once the data preparation is done, we split all the persona related data into question answer pairs as shown here. And we also went ahead in terms of trying to analyze the data statistics with respect to our data as well, where the first histogram indicates that the Pinecone vector database is uniformly distributed and normalized, where the vector value is mainly concentrated around zero, which is a good thing for us. And in the middle, we show the heat map in terms of trying to find the similarity between different documents, just to ensure that it all belongs to one domain of choice. And we also went ahead in terms of using tools like word cloud to get the gist of the domain data that we were using for this knowledge base.
So now we'll go through the model proposals, the model supports. We compare what the models between each other and the evaluation methods what we used. So at first, coming to model proposals, we have used GPT-4o, Llama 3.2, Gemma 2, and Mistral 7b. So comparing between these models, right? Although all the models use the underlying architecture of transformers, main difference is between the direction of contextual understanding, where GPT-4o and Gemma 2 are unidirectional, but Mistral 7b and Llama are bidirectional. Also, there are differences in trainable parameters and the data which it is being trained on. So coming to the comparative analysis of what kind of embedding technique we used and what vector database we used. So we chose Cohere embedding because the main reason was it has high semantic relevance compared to other embeddings, and it is can be easily integrated with a Pinecone vector database, which we have chosen because comparing to all other vector databases, it was very seamless and it had dynamic updates for data. If we change data if we had a need to change the vector within the database, it has an option of dynamically changing it. So these were the evaluation methods that we used to evaluate our models between each other. We used OpenAI and deep evaluation methods, where you can see accuracy stands for number of correct predictions divided by total predictions, fluency, and we also evaluated the models based on its query generation time. Yeah. So coming to the QFS, which we use to hypertune our models, as you can see, these are the QFS generated for Robert Kiyosaki and Dr. Sanjay Gupta, where we take this QFS and use it to hypertune our models. So this is the diagram of the training loss curve for Mistral 7b, which is being hypertuned. So we have taken Mistral, Gemma, and Llama from Hugging Face. So Hugging Face is a famous repo where base models are being hosted. As you can see, in this diagram, we can see what context from RAG is being taken and passed to the model, what is the query being given, and what is the answer being generated. Coming to the evaluation metrics, we can see that the base model, although, I mean, there is improvement in base model to hypertuned model in BERT score, in perplexity is being reduced, and coherence is increased. Although time taken for the hypertuned model is more because naturally it is being hypertuned with additional data. You can see a similar kind of training is used in Llama 3.2 and Gemma, where the training loss over steps is shown as a good figure, and we have used the same evaluation methods to evaluate the models. And naturally, there is an improvement from base to hypertuned. So this is the training loss for Gemma 2, also hosted by Hugging Face, the base model. Similar method, we have hypertuned with the QA pairs, and this is the metric being submitted. So this is of GPT-4o, which is hosted by OpenAI, fine-tuned with the QA pairs, and this is the metric that is being generated. Yes.
And yeah, over here in the slide, you can see GPT-4, which is fine-tuned with data uh, from thoughts of Robert Kiyosaki and Dr. Sanjay Gupta. Later in this, we have the comparison between all the LLM evaluation results. We can see like GPT-4o is performing with highest accuracy of 0.89 and a good query generation time of 2.9 seconds, which seems to be a top performer over here. It also beats a Mistral 7B and Llama 3.2 in coherence and lower perplexity. Highlights in this, the benchmark analysis highlights significant efficiency in real world applications. Going to the next slide, in the UI, we have deployed it via Streamlit for user interaction. It has been tailored for persona-specific queries and offers a streamlined user interface. Uh, in this, the changes from the earlier thing is we have included all the AI models and two different personalities, and we also have the fallback option for the personalities. Like if we couldn't figure out both the Sanjay Gupta and Robert Kiyosaki, it goes to the friendly assistant as a persona assistant, and we have new chat, and we have taken out the theme option, and we have automated it to the browser theme. Like whatever the browser theme is, our app takes the form of it. Either it can be dark or light. When you ask a basic question using a Sanjay Gupta personality, let's say, hey, uh, and when you click on the send, just a basic one. When you click on the send, assistance goes like, yeah, here's a picture of Sanjay Gupta to show like he's letting us know about any medical advice. So hey, give now let's say, hey, uh, give me advice on uh, malnutrition, let's say. And when we click on send, uh, yeah, it gives us all the information as a Robert Kiyosaki. So we also have the option of downloading the chat history, which saves in JSON format. And when you just change any model, let's say we go to GPT to Llama, the chat clears and we start from the basic thing. Again, if I ask to start the conversation, it gives us the answer. Although the answer seems to be different because again, the models are not the same thing. So every model we change, the answer also changes accordingly. But although it still stick to its domain and purpose. So yeah, going back to this thing, yeah. In conclusion, so we have we have proposed innovative persona integration enhances user engagement in finance and healthcare through expert personas. And we have included RAG framework combines retrieval augmented generation with advanced LLM for precise responses, and broader impact contributes to financial literacy, healthcare awareness, and educational accessibility. Coming to the future scope, we have what can we do in future is like we can go with the multi-domain expansion, planning to expand into education, legal, and mental health sectors. And we can also do a cultural adaptation which incorporate multilingual and cultural nuances for inclusivity. And finally, advanced modalities integrate audio, video, and sentiment analysis for enriched user interactions. Thank you.